I have a kinetics problem in front of me. It says the isomerization of cyclopropane to form propane is a first order reaction. And it's there. At 760 Kelvin, 15% of the sample of cyclopropane changes to propane in 6.8 minutes. What is the half-life of the cyclopropane at 760 Kelvin? And we have our answer choices here. So the one thing that I can pick up here is it's a first order reaction. So I'm going to be using the first order reaction formulas. The first one is this one right here, which is the initial concentration and final concentration and how they relate to each other with the constant here. And then the next one is our half-life, which is the 0.63 divided by the constant. So the first thing that I'm going to be solving for is this constant using the information that they gave me. So the Ln, and we want a final concentration, which is what that symbol means. So we know that 15% of the sample has changed. So we want to know what's still the same. So what we do is we'll just say, the out of the 100 percentage, we have minus 15%, which gives us 85%. So 85 of the percent is still the cyclopropane, which we're going to want to put here. But the one thing that I want to keep in mind is that we have 80% of what? It's not really given to us, so what we're going to do is we're going to assume that the initial concentration is just 1. So 85% of 1 is 0.85. And then we have negative k, what we're solving for. Time, which is given here, 6.8 minutes, plus the natural log of 1, which is what we made up, so we can get the k. So I'm going to grab my calculator. So we're going to solve for that. So the reason why we use the natural log of 1 is so that way we can just kind of cancel it out, because the natural log of 1 is 0, so we can just kind of void that for now. So the natural log of 0.85 is negative 0.1625 is equal to negative k of 6.8 minutes. We want to divide that negative 6.8 minutes. So we get this right here divided by negative 6.8. So that's going to give us that k is equal to 0.0239 minutes to negative 1. So now that we have k, we can solve for the half-life. So I know that the half-life equation is T half-life is equal to 0.693 divided by our k, which is 0.0239. So then by doing that, the 0.693 divided by 0.0239, I get 28.995. And by using our significant figures, we get that the half-life is 29 minutes. So we have our answer choice here, D.